Hello everyone, my name is Omar and today's topic is iterators. So let's start. Here we see what kind of methods iterator interface has. Each collection provides a way to iterate through its elements in some order. The iterable super interface of collection defines a method called iterator. It yields an iterator that you can use to visit all elements. For example, we create here collection and call iterator method. So here we used also two methods, hasNext method and next method. hasNext method returns true or false. Next method returns the element of the list. In this case, you can simply use the enhanced for loop like this. For any object C of a class that implements the iterable interface, the enhanced for loop is translated to the preceding form. The iterator interface also has a remove method, which removes the previously visited element. This loop removes all elements that fulfill a condition. However, it is easier to use the remove if method with lambda expression. The remove method removes the last element that iterator has returned, not the element to which the iterator points. You can't call remove twice without an intervening call to next or previous. The list iterator interface is the sub-interface of iterator with method for adding an element before the iterator setting visited element to a different value and for navigating backwards. It is mainly useful for working with linked lists. So we have here example. In our list we have two elements called Moscow and Paris. So previous method points to this element and set updates the value of this element. So we can trace this code like this. So let's consider some example. Here I created the linked list again called food. Here's the list of my favorite food. We call method list iterator. This piece of code is for traversing the list in forward direction, and this for traversing the list in backward direction. So let's run this code. Yes, we see the result. The purpose of the iterators is to provide a uniform way of accessing collection elements sequentially. So whatever kind of collection you are dealing with and however it is implemented, you always know how to process its element in turn. So in Java, the collection interface was made to extend the iterable. So any set, a list, or queue can be the target of for each loop, as can arrays. If you write your own implementation of iterable, that too can be used with for each loop. This example shows a tiny example of how iterable can be directly implemented. A counter object is initialized with a count of integer objects. Each iterator returns these in ascending order in response to calls of the next. So the iterators of the general purpose collection in the framework, array list, hash map, and so on, can puzzle novice users by throwing concurrent modification exception from single-threaded code. These iterators throw this exception whenever they detect the collection from which they were derived has been structurally changed. For example, the element was added or removed. So here's the example of concurrent modification exception. We create simple array list and add the elements. Here we see the loop that prints objects, but here we add one more element. So let's run this code. It throws us an exception called concurrent modification exception. So let's consider another example. We create array list again. We add elements and we called iterator. In this while loop, we add one element again. So this code also has to throw concurrent modification exception. Yes, it throws. So